Right now we're gonna be solving exact differential equation. So uh, here is our first uh, equation. So x minus 2y dx plus 2y minus x dy is equals to 0. So first thing we must do is to find or to test for its exactness. So first we must find the m in terms of y that will be equal to. So we're gonna derive these terms here. So in terms of y, so as what you can observe, there was just only x here. So we're just gonna leave it because it would be considered as constant. So that would be equal to 0 minus we have 2y here, there is a y, so we're gonna derive that. So y, that would be equal to 2. Only 2 was left here. So next is n in terms of x, that would be equal to, first we must simplify this, that would be 2y minus 2x. So 2y, there's no x variable, so we're just gonna leave it as a constant, so that would be equal to 0. Here we have 2x, there is an x, but it would be just uh, when we derive it, the only number that would be left is 2, because we don't have a bigger exponent here, so that would be my, or m in terms of y, and n in terms of x is equal. So we're gonna have to solve for psi dx is equal to, our dx is this terms here, so that would be x minus 2y dx. So we're gonna add for y here, that would be imaginary, or um, just for decoration as of this time. So there would be the integral of x dx minus 2 integral of y dx plus 9 of y. So that would be the, sorry, g of y. So the next thing is we're just gonna integrate this, so that would be x squared over 2, just the power rule, so minus integral of y dx, that would be 2xy plus g of y. This would be our psi. So next is we're gonna find the psi, or the partial derivative of psi in terms of y. So that would be psi over partial derivative in terms of y is equal to, so there's no y here, there's no y variable, so that would be leave as a constant, so that would be 0. So we're just gonna focus here y, so that would be 2x, negative 2x. We only have negative 2x left, plus there will be g prime of y is equal to, we're just gonna add this, that would be 2y minus 2x dy. So as what we can observe, in these terms we have a 2x here and then the 2x there, so that would be cancelled out. So g prime of y is equals to, um, 2 integral of y dy. So y is equals to 2y squared over 2, just the power rule. So as what you can observe, we can cancel this out. That would be y is equal to y squared plus c, don't forget the plus c. So just copy this for, in order to get the general solution, we're just gonna have psi x and y is equal to, that would be x squared over 2 minus 2xy, and then our y value, which is y squared plus y squared is equals to c. And then as what we can observe, we still have the denominator, so we're just gonna multiply it by 2, so that would gonna cancel this out. So that would be x squared minus 4xy plus, oh sorry, hindi na pala nakita, so just gonna move that, x squared minus 4xy plus, that would be 2y squared. 2y squared is equals to c. So this would be our general solution in this problem. So that would be it. Now for our second example for exact differential equations, we have uh 2xy minus tangent of y dx. So we're gonna plus x squared minus x second squared y dy is equals to 0. So first thing we must do, again, we're gonna test for its exactness. So m in terms of y, we have 2x minus the derivative of tangent, which is second squared, so second squared y, in terms, in term of x is equal to r x, that would be the derivative of x squared is 2x, then derivative of x secant squared y is, that would be secant squared y only. So as what you can see, they are equal. So they are equal. So next we must find for psi x dx is equal to 2xy minus tangent of y dx plus imaginary g of y. So we're gonna integrate these terms. So 2y integral of x dx minus integral of tangent y dy plus g of y. So this will be equal to 2 x squared y over 2, for this was the power rule, So minus integral of tangent y dy, ay sorry, this must be dx. So it would be x tangent of y plus rg of y. Now we can cancel this out, so this would be r psi would be equal to, it would be equal to x squared of y minus x tangent y plus g of y. So next thing we do is we find for the partial derivative of psi in terms of y. So this will become derivative of x squared of y is equal to x squared minus derivative of x tangent of y is equal to x secant squared of y plus g prime of y is equal to, we're gonna add these terms, so or the n value here, so we have x squared minus x secant squared y, so cancel, 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 so ry is equal to, I g prime of y is equal to 0, so our y is equals to c. So the psi of x and y is equal to x squared of y minus x tangent y plus c. So this would be our general solution for this exact differential equation.